Now that you have understood the concept of the parabolic framework to solve a problem, let us use it to solve a mathematical problem. In order to put our theory into action, let us use the equation in the above diagram. For those who prefer to directly read the diagram and join the dots by themselves, you can do so. This section is basically the text version of the diagram. So this equation is of the first degree. The first step is to read the problem until you can visualize it. What you can see is that there is an equal sign between two sets of numbers and variables. It seems that both sides are talking about the same variable y. Here, the left-hand side has been written as 5 into bracket y plus 3 bracket close minus 2 times y. The left hand side has been written as 21 plus 4 times open bracket y minus 1 closed bracket. In your mind, it's very important that even if it's a boring equation, you should be able to read it the way I have just done. Of course, it might seem a waste of time, but unless you complete the step one of the parabolic framework to solve problems, which is to understand it by being able to visualize the actual problem, then finding a solution will be more of following a procedure or rote learning than logical thinking or simply mathematical thinking. If you have time, you can ponder on what such an equation actually is telling. What does an equation also tell you something? Well, basically, this equation tells us that maybe in one experiment, y produced a certain result by combining with the numbers as on the left hand side, then the same result was produced in another experiment when y combined with the other numbers in a different way. Now you are able to visualize the problem. It's quite easy to understand how we can arrive to such a predicament where two different approaches leads to the same result. We can take two different roads from point A to point B and still reach from point A to point B. We can make X amount of money by different ways. Yes, you got my point. Now, the objective of this problem is to find an answer, which is to find the value of y in this situation as shown by the equation. Y could be the amount of fuel used or the seed capital used in the above examples respectively. But now you understand very clearly that you got to find the value of y, and that is possible only if you use the various rules of algebra and arithmetic to manipulate that equation so that you can come to the answer. So we come to the second phase of the parabola. We have to determine the theory, the theorems, and the formula that will need it to solve the problem. We have established that this is an algebraic equation and thus we'll need algebra formulas and rules. Also, since there are parentheses, plus, minus, and a multiplication on both sides, we'll also need arithmetics. Since you would be given the problem if you are in the chapter of algebra, then you would recognize this as a linear equation, and you will recognize that maybe the distributive property or the properties of equality that you just studied, and the BODMAS or PEMDAS arithmetic framework will be needed. For the sake of this example, let's assume that you have no clue of how to use those tools, even if you have identified them for this particular problem. I agree that this problem is quite simple, and you could use the tools that I've outlined, like the distributive property and the properties of inequality right away. But most students will encounter problems that they find complex, and this one might have been one also. So, just for the sake of illustration, I will stick to the parabolic framework that we're talking about here. So, this fourth step is to refer to the nearest example that resemble this problem that we are supposed to solve. Of course, you'd have to flip the pages of your math book backwards in order to find this problem. The fifth step is to read that particular example and dissect each step that has been shown in the book. You have to understand how the writers of the book solve the problem through each of the steps. How was step 2 derived from step 1? Then how was step 3 derived from step 2? How was step 4 derived from step 3? In this example, the first jump from step 1 to 2 occurred by using the distributive property. The second jump occurred by using similar terms. The third jump was used by isolating terms with the variables. And then the fourth jump was done using more isolation of a variable, using multiplications and divisions. However, many times the jump from one step to another isn't obvious. This is because the publishers of the book, in order to save on the number of printed pages, skip many intermediary steps. As a result, many students get confused on how a particular jump from one step to another occurred. They think that they are dumb, but it's not like that. So the sixth step is to not demoralize oneself for not understanding a particular jump. Instead, maybe that jump that did not show several steps involved a theorem, a theory or formula, or some rules earlier classes. Try to recall that particular jump and how step 3 transformed to step 4, for example. If you try hard enough, your recollection from your earlier academic, sometimes the students get an aha moment. They just recall that they had encountered this particular jump from a step to another step, but it involves many other intermediary steps which are not shown here. Voila, now you understood. However, if you still cannot figure out how the particular jump was made, do not let it pass and try to memorize. In the exams, you will actually forget what you tried to learn by heart. So the next alternative is to ask the teacher. However, for many students, this is not possible because for various reasons, he is not available. However, now we have artificial intelligence. So what the students do, and I demonstrated myself, is to take the picture of that problem in the example, crop it, then put it through an AI chat like Gemini. The advantage of AI is that it doesn't have a limit on the pages it needs to print in order to make a profit. So what AI will do is show every possible steps and even the intermediary steps that the book omitted. Once the student sees all the steps and all the jumps from one step to another, they get this blink in their eyes, the smile on their face, and a swollen chest. Now they understand. Now they are no more dumb. Now they feel that they can even challenge their top scoring friends. Still, if the student doesn't understand, he should go on YouTube so that there is a real physical person with a real voice and a video explaining that particular equation. Again, use the same cropped image earlier and put it in the search bar of YouTube. Today's children are really blessed by technology. Of course, they are misusing it, but it is natural, and naturally, the true blessing of AI will be recognized even by the most abominable cheaters. So, step 6 was the most important part of the parabolic framework of solving problems, as you can see in the diagram. It's basically the climax, and the phase 1 and the other steps in phase 2 were the rising or the climb in the mountain of problem solving. Next, phase 3 is the downhill or descending or falling, or basically the easy part of problem solving. As you can see in the diagram, all the steps are executed using the jumps that we already learned. If the book doesn't show the intermediate steps and jumps, the student through step 6 would have found them. So in the exams, the whole problem solution would be a natural flow of logic from one step to another through very well understood jumps consisting of theorems, theories, rules, definitions that are very familiar to him. As you can see in the diagram, by using the same distributive properties, operative inequality, isolation of variables, BODMAS and PEMDAS, the answer came as y is equal to 2. That was so easy. The hard part was always to reach the climax. From when the problem is visualizing it, understanding what it is that we have to find, then learning from the nearest example, and finally making sure that each step is thoroughly understood. Sometimes it might take several hours to decipher how from one step to another was made. When I was coaching my son in mathematics when he was in grade 10, there was a problem that he asked me about. We understood all the jumps out of a total 5 jumps, but the third jump we just couldn't understand. We used YouTube, Google, AI, books, and still we couldn't understand. So I told that we would sleep over it. Then the subconscious mind seemed to emphasize every research we did. So we were guided to Google's a particular question. Then found the theory or rule that was used in the particular jump solution provided by the book. Then it all made sense. Apparently, there were about 5 sub steps that were missing to understand properly. Again, at that time, I wish that the publishers were not so stingy to out so many steps of a problem just to increase the profits. Anyways, all I wanted to do was to highlight the importance of the last step in phase 2, which is the step of not compromising in understanding any of the steps and jumps. Thereafter is just a smooth ride home to the answer. Finally, as you can see in the diagram, a good student should explore the possible mistakes that he could do in solving that particular problem due to poor understanding of rules and techniques or just carelessness. In the above diagram, we have identified several mistakes that could be done, like combining wrong terms, using the property quality wrongly, or using distributive properties in the wrong manner. We could be making error in the sign. Also, in our rush, we might be forgetting the order of situation, namely BODMAS and PEMDAS. Finally, framework to problems come to a head, and it might seem tedious to go through this long process every time. The beauty of this parabola is that you don't have to do it every time. You just do it whenever you understand a given problem in the exercise section of the book. Then, the more you do this parabolic framework, the less you have to do it in the future. It's quite paradoxical, don't you think? But that's how learning, or true learning, harder you work, the less you have. So finally, even though this parabolic framework might seem hard work, I urge you to invest your time on it, because you'll reap the rewards in the future by not having to be confused and thus being unable to solve problems through exams. But the most beautiful aspect of the parabolic is that it's such an enjoyable process, and gives the student an endorphin kick at the end, which is incomparable to the dopamine kick that you would get by eating even or a quick answer. By all means, try out this parabolic framework for problem solvings.